Hello, my friends, and welcome back, everybody. How are you doing, chat? So, today we are going to continue our work on Super RPC application. So, today, so I understand what was my issue yesterday when I tried to implement the RPC layer between the Go application and Rust application. So I'll show you this on this chart. So imagine you have two, let's say, two applications, one written in Go and second written in Rust. So there are no problems to like communicate between them via gRPC, yeah? So gRPC is fine. This is the first point. And gRPC is fine because Go and Rust knows about the format in which they are communicating. So there are no problems with converting, for example, Go types into the Rust types and vice versa. Because all this hard work will handle gRPC, like protocol. Our problem is that we can't use gRPC actually. So because of PHP. So PHP is very slow. Let me check if there's an like PHP gRPC slow. Pickle install is slow. Yeah, no, it's not a protobuf. gRPC is slow. Like you can see, like almost a second, 700 milliseconds. So there are a lot. So generally, gRPC is kind of slow in PHP world. I don't know why. I'm not PHP developer, but this because of this we developed a new protocol based on like general RPC. Call this protocol GoRich. I guess you heard many times on the streams about this protocol. So this is a bridge, but most important that this bridge is based on a plain RPC, not JSON RPC, but just a plain RPC. So the second way to communicate between Go and Rust without any problems is JSON RPC. Yeah. So JSON RPC. So let's have a look at the JSON RPC briefly. So we have specification 2.0, and generally the message represented by this structure. So JSON RPC version 2.0 method, which we have to call from both sides, from the like Go or from the Rust side, and parameters here. So which we want to transfer to our servers. So there are a lot of types of like RPC call with named parameter, notification, non-existence method, and etc. So on and so forth. And so also good format, but we are not communicating via JSON RPC. We wanted to have the plain RPC, and the third one, plain RPC. Plain RPC. What does it mean? So plain RPC, there are no predefined format in the plain RPC. So you have to agree between your two services in what format you have to send. You'll send the data. For example, in our case, why we won't succeed yesterday when I tried to implement this application, because I tried to send a request with unknown format to Go. It's like request and it arrives in Go, and Go tries to decode this data within this information. So it's just plain TCP request. You know, so just plain TCP, so nothing fancy. But inside this plain TCP, Go expect to see two fields. First field is service method. It's like, let's do this do this way. Method and sequence. So method and sequence are represented. For example, if you have a look at the JSON RPC format, you will see this ID. So ID means this sequence ID, and if you send a message with sequence ID 1, you'll receive the sequence ID 1 as well. So this is kind of synchronization mechanism, like in TCP. You won't receive any other messages if you won't receive like block number like 15, for example. You won't receive the further blocks. And this is why UDP exists. So our problem that Rust packs all the data with just like plain data, like pack it in binary format, like just binary, without any structure in mind. But in Go try to unpack all of this stuff with GOB. GOP is like Go binary format, and GOP can be used to communicate between two Go services. So if you have one Go service and second one Go service, you can communicate with GOP between these two services, because Go by default send the data with encoded with GOP, and Go receive this data decoded with GOP. So easy peasy, you know. So thankfully to Go developers, we have RPC codecs. RPC codec Golang. Let me see if we have this in standard codec. Yeah. Yeah, as we see here in documentation, unless an explicit codec is set up, package encoding GOP, this is name of the package, is used to transport the data. So, and as we see here, we can use the function called, for example, serve codec, and pass a codec into this function. Basically, codec is represented by the simple interface, which like receive read request header, request body, write response, and close. So close, yeah, might be used multiple times as specified here. So basically these three methods should be implemented, and hopefully we already do this. We already did this. Let me open source, GitHub, Spiral Gorge. No, not Gorge. Since we're in Rust, Gorge RS. And here, as you may see, we already implemented our package format and package data. How we will be packaging our information from the Rust side and unpacking it from the Go side. So here, as you may see, where's our frame? Yeah. So we have this structure. This is kind of similar, you know, to this method and sequence and the actual data, but in our terms, frame represents the data we send. And inside the header and payload, inside the header we have options, and inside the options we have these two types which Go requires to have is method name and sequence. So we only need to do the following. To communicate with Go, we need to pack the frame, pack the sequence ID. So sequence ID can be choose randomly, so it's like just a number, or it can be used sequentially, like 1, 2, 3, 4, 5, etc., etc. So this is as a client, this is our task to set a proper sequence ID. Okay, so our task for today would be to properly send the data, where's our, yeah. Here, as you may see, we just our payload is just like this. Test method to own plus hello from Rust. Like that's it. We are not publishing a frame, which is important to handle in Go. And in Go, we also where is my syntax highlighting? Once more time. Where's my syntax? Neovim, you are drunk. Yeah. We have LCP up and running. But Go is drunk. Okay, so let me try to recompile. So let's use latest nightly version of Neovim. So yeah, I'm using latest version because I have this inside Neovim. We have this bug with dep UI, and yeah, I can't use basically dep UI with this bug. And let's and git pull. Let's compile. So this is kind of easy to recompile everything. So no, completely no problems. And yeah, there are problems using nightly versions like from master. Let me see if there are new versions of Neovim. No. So still waiting. So I'm waiting like basically for the 0.9.1 release actually. Yeah, and helm weather project cache release sudo move treeseed user bin. Yeah, and go back. Project Gorich, no Gorich, I guess here. Yeah. Okay. Should be fine now, I guess. Still indexing. Yeah. Yeah, some problem were here. I know type checking error pattern directory prefix doesn't contain model. It's so yeah. Also, we have a problem with. I have a problem here with Go is worrying about that it is located inside the tests folder. Like it can be any folder, so with any name. But the problem is that Go is worrying about it. Okay, so this is like nested folder. I can't figure out where I'm. Okay, so and here, as you may see, we are accepting just a server connection. So that means that we used a like codec represented by Go. Yeah, just like basic codec. Go definition and serve connections, you see here, and GOP server codec. So this is like not that we should actually do inside the application, but instead we should use our own codec, which can decode our format. And hopefully we already have this codec. We only need to no, terminal. I wanted to terminal. Go get -u github.com RoadRunner server Gorge version 3. Oh, sorry, no Gomot actually. Okay. So now we have Gorge installed in our Go models, and what we need to do now, we let me have a look at the tests. So how we can import this so my package, how we can import my package, yeah. So we need to use listen RPC serve codec, yeah, Gorge new codec and connection, yeah, actually like this. And but not Gorge github.com RoadRunner server Gorge version 3. Do we have a codec? No, I think we don't have a codec. Gorge should be like this, I guess. Yeah. Could you please go to definition? Oh, no. It should be Gorge, and package is called RPC, as far as I remember. Yeah. RPC new codec, yeah. RPC and Gorge, yeah, should be fine now. Could not import. No required model provides package. Why? Could not load the import. So why you could not import this? It should be inside the RPC package, yeah. RPC. Oh yeah, it's PKG RPC. I'm sorry. Yeah, so I hate this PKG, but I can't. So it was like introduced, like, you know, just temporary solution using the PKG, but I just can't. So I can't remove it because it will break change. It will like break all other packages, and removing only PKG folder. It's like for the version 4. It's not like what I wanted to do. Let me check why you can't. PKG. What is the actual name? Why? Like this? I don't understand this magic. Should be like this. Why is like arguing me? This is a test. Let me check. And let's search Gorge version 3 package RPC. Yeah, so this is exactly the how it should be. Why it's like arguing me? Search RPC and oh, new client codec. What? Oh. So why? No, it should be. So for accepting connections, it should be. So yeah, this is how how I'm planning to implement the things. So for the server part is Go part. I need to use like new codec. It's like server part. But for the Rust, I will use new client codec, but like implemented in Rust. So I don't need actually to, to implement this in Rust. But I know that the like request, how to form the request. I know how to do this. So I only need to, to encode in this format like this, like here. So I need to write a source method, like write flags, like etc, and yeah. And we are using this GOP here because we are not sending requests from the from other systems than Go, So we only send requests to RPC only from Go, and because of this we are using this codec GOP. It's like convenient codec name for the for communication between Go and Go. Okay, so it should be a new codec. Why you are arguing me? Could not import package. No. Go mod. What? Go, you're drunk. Should be like this. So yeah, there are definitely problems when I open in there are errors. When modules have errors, and nonetheless also arguing about errors. Okay, boy. Now object found for ident new codec. Undefined gorge, for sure it's undefined. Yeah. Now it's fine. So what was the problem? Go, you're definitely drunk. Go home. I guess the problem is still that we have to define, so how it's supposed to work in Go. If you have nested folders, like me in the tests here, I guess Go expect me to have Go mod as the root of this module, and Go work as well. So Go work, it's like a new introduced, I guess, in Go 1.18 new files called go.work, in which you can separate like binaries. For example, you can use folder as a module, yeah, and specify it in the root of your directory. I don't want to to spread all of these Go files outside of test directory, because this is used only for tests. So I don't need for them to be like outside of this test folder. I don't want to see these files. Okay, so fine. So now using this new codec, so basically this is our codec, and we will send the request with our codec. Where is our read store, read request body? Yeah, as you may see here, we are going to receive from Rust here a frame. So this is very important. Here we just yes, this is right response, but where's our read request? Yeah, read request header, for example, like this. Yeah, as we see here, we just receiving a frame. So we are getting frame from the pool of the objects which we store in Go on Go side, like to reuse the frames, because they are quite heavy objects and can contain big buffers. So it's rather like advantage of store them than just like create and destroy on a recall, because it can be this might be a very high performant place and very hot place, hot place. And we are receiving from the relay. So relay, basically what is relay is our transport, so it's our socket. So we are receiving data from the socket, or it can be TCP socket, it can be a Unix socket, it can be even Windows socket. I guess it's called name it pipes, something like this, or it can be inter-process communication. So we can also communicate between the processes, and we are receiving the data from here. And this is like an error handler. We can, if there are some errors, we just put in the frame back. And as you may see here, we are resetting this frame. So like resetting is to initial state before we put this data in this frame, I'm sorry, to the back to our storage. Okay, so, and as we see here, only one thing we need to do from the Rust side is to pack our request into the frame. And as we see here, we also have these two sequence and service method Go specific things to handle RPC requests inside. So this is kind of similar to JSON RPC, as I mentioned before. But as we see here, we have a sequence and we have a service method. What they are and where we get them. So where's my painting studio? So we have basically a frame, yeah. So frame is our Gorge frame, like, and we have a header inside the frame, yeah. It's kind of similar to TCP frame, but yeah, contains our information, so our specific and it modified to fulfill our needs. So somewhere from we have an options. So if header len is more than 3 means like just 4 bytes words, so it's like more than 12 bytes. And why exactly this side with exactly this size? Because where's documentation? Yeah, so frame right now. So because of this, so we have stored only basic information inside frame, like version, header length, flags. Flags basically needed to like provide some information about the encoding of the data, so to correctly decode it from when we receive it from the socket or from the process pipe, or etc., etc., so on and so forth. So here we also encode a payload length. So we need to distinguish, so because we are receiving like a big pipe, so imagine you have like a big pipe, like boom, on the table. So, and you don't have any node where is the meat in this pipe. So having this node here in this case is our protocol frame. So having this node, we know that, okay, bytes number 2, 3, 4, 5 contains payload length. Okay, so we just can cut them from this binary sequence, and so decode it and have payload length. And if, so important question, how to distinguish between the header and the actual payload, since we only have a big pipe, you know? So basically, we know that the data that our payload should start from version. This is the byte number 0. Then, right after the version, we have header len. So header, you can't just, so basically you can represent it by allocate like, I don't know, 8 bytes and represent it by int 64, for example, or have like 4 bytes, and in 32 we have slightly different techniques. We have words, number of words. Word in our case is 4 byte, like 4 bytes, just 4 bytes. And if we have header length equal to 3, we only have this part, like up to 12 bytes, up to this. So no other information we receive from this socket. So only just version, CRC sum, some flags, and payload. In this case, we can just cut at the byte number 12 and decide. So for the left side is our header, right side is our payload. Done. But if we want to encode information about the options, like here, like it encoded inside general TCP frame, you know. So if we want to encode an options might have a variable length. It can be, for example, in our case, sequence ID, which is int, and service method, which is string. We want to encode this. We can't encode like super big, like a lot of the information, but we can encode up to 40 bytes of information. So your method should not exceed like 40 bytes. Actually not 40, I guess 30 bytes, because we also allocate for the sequence, we allocate 4 bytes for a sequence, like 36 bytes should be your limit to your method name. So it's, you know, kind of big method name. And yeah, so on the Rust side, we have to encode this information into the frame and pass it to the Golang side. And yeah, so we are going to do this to do this now. So hopefully we already did all of this header like work and header framework with in Rust. We already did this in our Gorich res package, which we did on the past streams. The only thing we leave in, yeah, we leave here is actually reading and writing into the pipes, but we actually don't need this. This is needed for the RoadRunner worker. This is not needed currently on our stream. We only need to have this model. So I guess I have a version for this. Let me check. Gorich RS. Yeah, so I have a tag 0.1.1, and I guess it's fine to use for us at the moment. Yeah, mod. So what we need to from this package, from our package, what we need from our package. First of all, we need the methods to write a payload, which we are going to pass to Go, and we need to have an options to pass a method name which we wanted to invoke, and sequence. Yeah. Okay, so let's do the math. Let's write. Oh, don't need this window anymore. Okay, so we need this. Oh yeah, the dependencies. Nice. And we don't need this anymore. Okay, so we only need Rust, and for the Rust we also need our cargo toml. Is Gorish to equal to? Let me just check. Cargo toml Rust GitHub package. So it's not published to the cargo. Oh yeah, git. So basically we can do like this. Only git without the version, like for sure we can do this by path because it's all local. But let's do this like in the form, in a more convenient form. So the version 0.1.1 and GitHub.com, RoadRunner server, and Gorich RS. Cargo, please reload the cargo check failed. HTTPS GitHub.com, RoadRunner server, Gorich RS. Yeah, perhaps I meant this. I think it should be tagged, maybe. We have a tag. Because actually this is not release version, you know. Gorish, yeah. Why it's... Oh yeah, tag. Yeah, so we have to use a tag. Yeah, okay, fine. So, and now, where's our main? And here we should use our, so we don't need this. This stop. So yeah, we don't need, at the moment we don't need you. Sorry, you. We only need to experiment with our Rust server. Okay, so next we need to form a payload in a proper format. First of all, let's use our Gorich frame default. Should be like this. If you import default, refer to it directly. Do we have direct default? Or we have new? let's see. Where you are? Okay, so do we have implemented default? Oh, no, we don't have. Yeah, oh yeah, we have default. Yeah, default implement for frame, and this is located in the frame flux. If I public mode frame. Yeah, this is our experiment with, so on the next streams we are going to re-implement the pipes logic, because we can't use, like in Rust, we have mutual references to kill and mutual reference to wait within one command, so we can't use wait and kill the process at the same time like we can use in Go, unsafe Go, compared to Rust. So we have to we are going to implement this with using system pipes, using OS pipe 2 system call. Yeah, we already did this for Unix. So actually copy this from Nux and the OS pipe I get package. Yeah. Okay. So let me just. This is a different plugin, I'm sorry. This is actually what I'm working for on work. This is like log plugin. We not have. Oh, it's under. Okay, let's see. SDK worker. Let's see how to use this. I should have a test somewhere. Yeah. Frame default. Yeah, and frame. Gorgeous. Oh yeah. Not directly. Yeah. Not frame, but frame with uppercase letter. Yeah, like this. And also we can for sure use like this and okay, so we have method with the name test method. Frame right version 1 frame right options, and we're going to use an array here. So options, first of all, sequence ID, and we also had to encode let me check how we do this. Write request. Okay. Oh, we are writing a string. Okay, so inside the buffer. Write options. Oh, yeah. Options should be. Oh, yeah. So I was wrong. We are writing an options just as offsets. So I'm sorry, I developed this 2 years ago, maybe 3 years ago. So it's forgive me my memory. So we need to write a sequence and then series method as options, and this would be our offsets. And then we actually using a buffer, so we're having a buffer, writing a string inside this buffer, yeah, and then encoding the body. Yeah, so this. So we're going to encode this in, I don't know, in some free format. I know by free I mean like. So we have a protobuf, and I'm going to use a protobuf. I just need to verify that everything working fine until stage when we are unpacking the data from the protobuf. So we're going to use frame proto codec. Yeah. Okay. So I just need to think where are we writing this buffer. So we're getting the buffer. Yeah, this is a pool with buffers. Buffer in Go, buffer, if you don't know, represented is just some extendable slice. So you can use a slice for sure instead of the buffer. But if you need to, perform some kind of write string operation, and you have a byte buffer, so buffer in Go just helps you with all of the separation of converting like strings into bytes actually. So okay, so what we're writing here, if body is not equal to nil, we are going to write this codec proto marshal and writing also into the buffer, writing our data, what we sent actually to the recipient. Oh yeah, so buffer is our payload. Okay, get it. So we need to do let me think. We have sequence ID. Yeah, so we can just write 1 because we have only 1, and we have let method is equal to test method. I'm sorry, wrong quotas. So, and we have to method len as u32 do like this. Okay, write inversion options. Let's write our payload in this format because it's like just a string. Hello from Rust. And frame write payload, and I think it should be like vector. Yeah. So what's the difference between Go here is we don't need to write payload len. So because this is where's our 4? Yeah, so here we are writing a payload length and we are writing payload, but we actually don't need to do this because we can combine these two operations, so it's not necessary to separate them. I realized this too, only after I stabilize this interface. So I have to write rather third method, write p, something like this, which can implement both without, so to implement this without breaking changes, or just to like write all of this method. I don't think Gorich is used, like, you know, widely used by someone. Let's just check if it's used. Yeah, so no, basically no one uses it except, oh, I think do we need to where is this fancy, you know, imports, like who imports this package, you know, this kind of statistic should be somewhere here. Why it's version 4? It's version 3. What? Oh, it's Gorich PHP. What? Oh, this is not correct. You see this? So it's like, yeah, this is not correct. It should be like this. It should be like this. Okay. Oh, we already have this. Go reference. Yeah, should not be PHP version here because it's like, you know, confusing, because actual version of the package is version 3, but PHP version is moved further up to version 4, and this is like, you know, I guess it's confusing slightly. Bypass rules and commit to the readme. So I did a crime. Okay, so what is actually playing here? I can turn on some good music, I guess, because it will be immediately blocked by Twitch. Okay. So fine. We are encoding this write string, then write. Oh yeah. So we should also encode a flags frame. Write flags and Gorich res frame. Frame, I guess. I think it should be like frame flags, no? Frame? I guess it should be like this. Let me double check this. Yeah, frame flags, yeah. Frame flags, oh, it's private. How it could be? Oh, I guess so, yeah. I guess I need to point to the local directory, yeah? Because it's like, it's private. I opened this. Yeah. But in the version 0.1.1 they are used as private. Yeah. So let's just use a master version. And try this codec. What is... Oh, yeah. So it should be a slice. Okay, so we wrote a flag, yeah, options, payload, and then we need to write this frame as bytes. Expected U8. Okay, so we also reading some information here. We don't need to do this, and I think this is it. Yeah. Let's go to the go. Let's go to the new. I'm sorry. Go to definition, and this is the right. Yeah. So we should be stopped somewhere here. Read request header. And read request body. So yeah, somewhere here. Okay. So yeah, let's start the actual. Let's start the fancy part, debugging. Yeah, okay. Let's go on. File to... What? Fuck, could not load expert data. Let's open one more time. Go, please. Oh, now we have to put our breakpoints from the beginning. So write response. Okay, so handle error. We don't need this. And read request header. Breakpoint here and read request body breakpoint here. Let's go. Why? So it looks like everything's fine. Where's the logs? Do I have DLV? Yeah, I have it. Style person. I guess I changed something in my configuration. So Houston have a problem. My version is too new, or so can we debug the test? No, so we can't debug. We can't debug anything. So definitely something with configuration. Let's check what I changed. So I guess everything worked on this checkpoint. Let me see what changed from this time. Okay, require might be I need to okay. And wind up logs. So there are only problems with Go. Okay, so we have neodev, virtual text. This is fine. We have configuration for and wind up UI. We have configuration for the Go. Basically, this is super primitive configuration because we only have like dub configuration and delve. So we basically don't need to do this. Let's try to restart. I know, might be something with too recent NeoVim version, I know. I guess the problem is that I updated the NeoVim version, so let's try to downgrade it slightly. Let's try to install just stable version, you know? Oh yeah, so we need to write. And let's try now. No. What the is going on? This is one of the reasons why it's hard to move to NeoVim. So I didn't change anything, but suddenly it stopped working. Now I have to figure out why. This is not the reason to not to use NeoVim. It's just, I guess, the problem that I did something in the configuration might be. So error to launch. Dub show logs. Oh, what? It tries to run Rust. Dub set log level debug. Okay. Session closed. Dub show log. Okay, so file to check the debug console for the details. GC flags, no required mod provides GitHub, go mod file found with current editor. Fuck yeah, so it's like, this is stupid Go. So I just don't know why. This is my first point, why not to use Go. In 2023, almost a year ago, Go is like invented in 2012. Released in 2012 March. And at this moment, there are a lot of the good packaging managers, like Composer, even Composer from PHP. So like a lot of them, but no. Go first of all decided to use just folders. Yeah, exactly, just folders with name. I forgot Go modules or no Go modules. I forgot, it was so long time ago. You definitely should put an GitHub repository into some folder, and then Go will find it. So it's super stupid decision. And then they just like developed models. There are like I forgot the names of this third-party package managers, which was invented for Go because of this super stupid Go official package manager. Ends it now. So everything is fine here. You just locate it in this test folder. So nothing wrong with it. But no, so it's like debugger is trying to start from the folder, from the root folder, and it can find this model because it's like Go mod existed here. It's so stupid. So with Rust, you can put literally anywhere your file and like debug without any problems, and put cargo toml in any folder, so without any problem. You should only specify like a path. Oh my god, so this is so stupid with Go. Okay, debug with arguments. So but args here is just race, so it's like not where is it? It's not needed one. So yesterday when we debugged Go, that was no problem because we used only so without Go mod, and so it was only on one file. We not need it anymore, so only like Go mod, that's it. We don't need it Go sum, which is actually contains like hashes of the modules. Okay, so we're how to debug in. So for sure we have options. So we can syntax highlightings. We can create like custom target. So we can create a custom target to point not on this spiral Naivia path, but spiral Naivia tests. Not found in this directory. Yeah, so go build -o. Oh, actually, I don't think. Let's just try to build by ourselves. So what does mean this command? I'll explain you in a second. What is this? What is this? What all of this shit is? No syntax, seriously. Thank you very much, Go. So, I don't know what is current directory here. So go mod file, not any parent directory. So I guess. Oh, yeah, this is full command, I guess. So GC flags means all -n -l. Please remove all optimizations of this binary, so to debug it properly. So some bug or like the thing you're searching for will not be optimized and like removed. For example, if you like using something like this, like var a is equal 1 to 1 plus 2, and then printing this, Go, I think, replace it with just print 3, because it's like known on the compile time what is happening here. And because of this, this is like a very simple sample, but in other samples, for example, some inlinings, or it's super cool to use this GC flags, all -n -l, to remove all of the optimizations from the binary. And go build -l. I guess it should be like this. Oh yeah. Everything's fine. So the problem is that this debugger can't jump into the folder, into the current folder. So the actual problem is that we have this test folder, yeah, and debugger is trying to invoke go build command from this one, from the root folder, but actually we have go mod inside it, inside the tests. So we can create the custom target. we can basically add to the dub. Yeah, so we can add to the dub go. Oh, I'm sorry, not to the dub go, but to the dub and vim. Let me see, where is this wiki? Yeah. Oh no, not this one. Yeah. And request here. Oh, can we add this dub go and vim? Can we also populate some targets? Oh yeah. I guess this is what we needed. Attach remote. Let me try to do the following. I want to just copy configuration from this from Visual Studio code. You can't even run it. Yeah, you can. And let's see that DOV dub listen. Yeah, this is correct. Where is the configuration? So as we see here, create a line JSON file, add configuration for the Go. Launch file, debug, and file. Yeah. And this is interesting that must be valid directory or Go file. Oh, we can't. Yeah, we can't. We can debug JSON. would be fine to see how to debug JSON actually. Okay. So yeah, this is correct configuration, you know? So this is like a name, launch file, request launch, debug, and file. My question is why NeoVim, or more specific, to be more specific, this is not a NeoVim problem. This is problem of the dub adapter I'm using. Oh yeah, this is created by the NeoVim. Yeah. Oh, I'm sorry, Visual Studio Code, Visual Studio Code. Why it is trying to create a file in the root directory. If there's an dub continue, dub go debug test, dub go debug last. Yeah, so I need to register an 1, 2, 1, 2, 2 open square brackets. Why it's so much additions here should be added. So okay, we don't need this. Okay, so and let's see what's name launch file. So this is at the type go mode debug request launch mode debug. And the arguments are like program file. Okay, like this. Oh, yeah. Okay, let's see. Yeah, we have this target. Okay, so stupid go. Maybe I need to add this package to this. So it's like might be able to be better to start from okay, let's at this moment let's start. I just want to see if we are right here. Let's put the breakpoint here and put the breakpoint here and launch the server. And cargo using cargo run. Connection refused. 18999 and what's inside go. Yeah, the same. But we have an error here. Where's the stop button? Oh, permission denied. What? Yeah, everything's fine now. Error is nil. Yeah, so we're fine. And now let's run. Okay, we see. Yeah, as you may see, guys. Now we received a request. So what's inside this request? So we have a. So we don't have this information, service method and sequence, because we need to decode our frame. Let's say, yeah, we receive a data. Oh, we didn't receive a data. Undefined data. Oh, voltage failed. Yeah. I forgot to write SRC. Should be like. Oh, this our famous bug. So since this is not a problem of the NeoVim, let's. I just needed to like remove and my old build files to like to start from the fresh installation. So let's. Okay, let's start once again. Yeah. SRC, main.rust, frame, write CRC. Yeah, good. And now we needed to restart our. I don't know how to name this technique of debugging. Shitty debugging, I guess. Okay, and cargo run, hit the breakpoint. Oh yeah, now this is super cool. As you may see, we received a frame, yeah, as expected. So as you may see here, we have a string hello from Rust. This is our data which we sent from Rust. It's super cool. We actually did this. Hooray! Okay, and we have a header. So this information coded in header should contain options, and options should be a type, yeah, of two, 1 and 15. So 1 is our sequence, and service method. Let me decode this. Yeah, and now we populated Oh, service method is hello from Rust. Yeah, so not true. Okay, so let's update our, update our oh yeah, update our algorithm. So I forgot to write method inside a payload. How I can do this? So let me check. How we doing this inside a gorge? PKG, RPC, client-server test. No, inside a codec and no, inside a client. Write request. Okay, so we are writing a string, which is our service method, yeah, and we are writing this inside a buffer. And then imagine we have a nil body, okay, and then we are writing the data as well inside the buffer. So first should be a method, yeah. First should be a method, and then let me just let foo is equal to method plus payload. Can we do like this? No. Let's just do like this. Hello from Rust. Oh no, we can't do it like this because we should know length. This is two strings, and we can definitely format them. Let res is equal to format like this, method and payload. Yeah, like should work. Should work. Like, yeah, sure. Should work now. Unused variable, and yeah. So here we are writing inside the options. We are writing sequence ID and length of the method, and then we are writing a result like this. Okay. I think it's good. No, not so fast. Codec and run and debug. Cargo run. Receive. Everything is fine. Options 1 and 15 and service method. Yeah. Now as you may see, we correctly pass the data, and now the service method is test method, and as you may see here, we registered this name, and I think read request body. Oh yeah, I think it should be an error here. Yeah, message is not a product because yeah. So because message is actually a string. That's might be. Encode it with codec row might be would be fine. Codec row. We also should import it. Codec row. So it's I don't know, it's super stupid, guys, to like, so debugger in NeoVim doesn't work at the moment, so we're starting the debugger from Visual Studio Code and debugging those two parts of the program with, like, we're debugging Rust with NeoVim with all cool stack, and Go with all of this Visual Studio Code, and you know, so it looks super funny. Yeah, so now we should, I guess, should be fine here. Cargo run. Okay, next. Yeah. We have nothing inside this test method. Because actually we packed the data. I don't think that we packed it correctly. We'll resolve this soon, but as you can see here, we are able to call on a general PC without like gRPC, without dealing with all these Go formats on the Go side, and dealing with all of this stuff on the Rust side. We are able to call an RPC method. We are just general TCP, you know, TCP stream, so it's like super standard library, I guess, and we are able to call with our own format the method from Go. So this is cool. This is super cool, I think. What we need to do next? So first of all, I want to figure out why we have we can't parse the data. So let's see. Read request header. So this is everything's fine with header, but something is bad with. Let me check. Where's our? Oh yeah, something is bad here. When we parse our just codec row. Yeah. This is not a byte, actually. This is this is our out function, and this is not a pointer on to bytes, you know. This is just bytes. So let's how can emulate this? I guess we can't emulate this on the Rust side. So we just needed to have keeping in mind this. Okay, let's see the actual data. If we receive at least something. So we need to put a breakpoint somewhere here. Boom, and stop the debugger. Run it again, and run cargo. Boom, we are here. Reading frame flux. Yeah, and now we are inside this option. So do we have any options here? 1 and 15. Yeah, so this is our payload, and this is our actual payload, and yeah, we are receiving the payload. This is super cool, guys. So we have this payload actually, but The problem is that we needed to add also a type string to go, like to keep it in mind that we can send just a string and it would be treated as a row, you know. And yeah, so I don't want to do this at the moment, but so if we oh no, so yeah, so we are returning nil here and row, appending this I guess this is just incorrect marshalling in this place. So this is also kind of interesting going technique, I don't know. So actually type, which is here, like coming inside in our request read request body, is actually this is type which we need to return. So this is super confusing in terms of API at all. Like read request body, you're expecting that you needed to read some, you know, body, yeah. But as you may see here, we are receiving everything from the frame, and we are unpacking the data into this out. So yeah, and we are doing this because I don't know. So let me double check if message is correct for instead send an error. So where we use this p out. So I only have this and then immediately close. It is JSON, no. So it's like kind of outdated API. Yeah, so what's happening here? Actually, this row, there is pointer to our out. And we are appending to so we are dereferencing the pointer, which is actually our out, and putting the data inside this pointer, you know? And so this is super confusing. So yeah, it's low level API, and yeah, I guess it should be super confusing. But no, I just can't prove it to myself that it should be super confusing. So, oh, we can't actually write this. Okay, so we solved our purpose for today. So we definitely can send data. So what was the goal, as I mentioned before? So we should be able to send data from Go to Rust via our protocol. We did this, and this is super cool. Next step, I guess tomorrow, we are going to update our protocol and write an actual protobuf data. So we needed to use inside Go. Where's our Go? No. Here. So we're going to use inside our test method, in the in and out arguments, we are going to use a proto, you know, and so we will be able to use codec proto, and then it should be like full cycle of the encoding and decoding data from Go to Rust. And after this, since we would have all of this, so I guess we just wrap it into some like pretty API, like to provide like a method and payload, and then under the hood it will convert everything in and write a frame. So not to like, you know, to expose low-level API to the user. So we are going to write this. And why we need this actually? Why we need all of this stuff for our like monitoring tool? So because all information we can like obtain from our application is from RPC methods. So it's not some kind of HTTP endpoint which we can ping it and get the data. All of the data are received from the RPC. Since it's local host, it's, you know, it's pretty good. So it's no there's no, you know, latency penalties or different things like this. So it's completely fine. And we also by the way, let me put a breakpoint here and read to end, and I think it should be vector, yeah, and it would be a vector. Yeah, like this. Let me just check one thing. So we don't need to start Go in a debug mode anymore. Instead, we need to start in debug mode Rust. Let's now check how Rust will handle this problem with starting in debug mode. Okay, go run. So we stopped this. Okay. We already stopped this. We can close it. Go run, and we can go to our main and let's try to debug. Oh no. So it's test build Naivia. So it's first. Yeah, Rust, you know, is cool. Yeah, and we needed to read the data, read to end. So I guess hello from Go. Yeah, we call this method. Oh no. We actually didn't send anything. Yeah, let me do the math. Out is equal to hello, fellow user. Okay, so this will help us to okay, go run. And now where's our Rust? Stop. No. Vector. What is it? So still have this error. Oh my god. Rust last debug. Good. And what we have inside our buffer? I guess nothing. Yeah. Size is empty. Yeah, this is kind of interesting to me. Let me just double check this. How we have actually, so inside our server function, do we have, so we have a new codec. Yeah, this is, and write response. Oh, yeah, so we should receive a frame. Yeah, so it's not a vector. Yeah, let mut flex frame, frame default, like this. No. So we can't read still this error. So it's like kind of super bothering me, guys. This problem with debugging and all of these bugs. I don't know. So might be why? Just why? So I need to switch back to version 0.3 might be, so without this behavior. So yeah, I guess I'll switch to like previous version. So okay, guys, today we did all of our tasks I planned for today. So we sent a payload to the Go, and I guess to receive the payload from the RPC from Go, we needed to encode all this with protobuf. Yeah, because I think we just can't decode correctly the data. And since we are going to decode all of this in protobuf, we also should, after receiving, we should unpack the payload correctly. Okay, so this is task for tomorrow. And as usual, thank you very much for being with me, guys, and have a great evening, and see you tomorrow. Bye bye. See you.